Ever wondered how we can build AI that doesn't just talk, but does? AI that can understand complex requests, use tools, and even collaborate with other AI to solve real-world problems? This isn't science fiction anymore. It's the world of agentic AI. But building these sophisticated AI agents can be complex. You need the right tools, the right framework, and a way to manage all these moving parts. That's where Google's Agent Development Kit, or ADK, comes in. I'm your guide, and in the next 10 to 12 minutes, we're diving deep into ADK. We'll explore what it is, its core components, how it stacks up against other tools, and most importantly, I'll walk you through how to build your own first ADK agent using Python. Well, first, we'll look at what the future holds for exciting technology. We'll even look at what the future holds for this exciting technology. So, if you're a Python developer curious about AI, or an AI enthusiast, if you're a Python developer curious about AI, or an AI enthusiast ready to build more powerful application, you're in the right place, and let's get started. First things first, what exactly is the Agent Development Kit? At its heart, ADK is an open source, code first toolkit designed to make building sophisticated AI agents feel more familiar software development. It's flexible and modular, allowing you to create everything from a simple agent that performs specific tasks to complex multi-agent system that can tackle intricate workflows. Think of it as providing the robust scaffolding you need to bring your intelligent agent ideas to life. ADK is built on several key principles. It's model agnostic, meaning while it's optimized for Google's Gemini model and Google's cloud ecosystem, you can integrate it with wide range of other language models or LLMs from providers like OpenAI, Anthropic, or even open and local models like via LLM Lite. This flexibility is crucial because it allows you to choose the best brain for your agent's specific needs. It emphasizes a code-first development approach primarily in Python, with Java support recently introduced. This gives developers fine-grained control, testability, and versioning capabilities, which are essential for building reliable and maintainable system. This developer-centric design philosophy means you're not locked into a restrictive GUI or GUI. You define agent logic, tools, and orchestration directly in code, offering ultimate flexibility. ADK is also designed for multi-agent architecture. This is a powerful concept where you can build modular and scalable applications by composing multiple specialized agents that can collaborate and delegate tasks. Imagine a team of AI experts, each with a unique skill working together. That is kind of system ADK helps you build. And because these agents are designed to be modular, they can be reused across different applications, promoting efficiency and consistency. So, what are the main building blocks? ADK revolves around a few core components. First, the agent themselves. These are the core entities. You have LLM agents powered by language models, workflow agents by like sequential or parallel agents that manage execution flow, and you can always create a custom agent for specialized logic. Then tools. Agents aren't just thinkers, they're doers. Tools gives agents capabilities. These can be Python functions, APIs, pre-built tools like Google Search, integrations with third-party libraries, or even other agents. The rich tool ecosystem is a major strength. The next is models, as we discussed, are the LLMs that provide reasoning capabilities. ADK's integrations with Light LLM makes it incredibly versatile here. Um, the sessions and memory are crucial for managing context and conversation history. allowing for stateful interactions. ADK provides mechanism for this, including in-memory session for local development. And finally, orchestration. This is where you define the control flow, whether it is a predictable pipeline using workflow agents or dynamic LLM-driven routing, where an agent decides the next step or which other agents to involve. This ability to seamlessly blend structured workflow with intelligent adaptive behavior is the key to building truly sophisticated systems. Now, you might be wondering how ADK fits into the broader landscape of AI development framework. Traditional agent-based modeling, or ABM, framework are often used for simulations, focusing on the emergent behavior of many simple agents. ADK, while capable of multi-agent system, is more geared towards building functional, task-oriented AI applications that leverage powerful LLMs. While we look at the other AI SDKs, like LangChain, um, is very popular with a vast ecosystem of integrations. AutoGen excels at multi-agent conversations and research. The Crew AI focus on collaborating AI agents with AI agent teams with role playing. Strands from AWS emphasizes a model-driven approach, letting LLM handle more of the planning. ADK distinguishes itself from its code-first Python and Java-centric approach, deep integrations with Google Cloud ecosystem, especially with Vertex AI uh, agent engine for deployment, and a strong built-in design for hierarchical and collaborative multi-agent system. It aims to provide developers with precise control and building blocks for robust production-ready agentic applications. It is also a key player in open agent-to-agent protocol initiative, pushing for interoperability across frameworks. Well, enough theory. Let's roll up our sleeves and build a simple ADK agent using Python. So our goal is to create an agent that can tell us the current time in different cities. So the first step is to set up our virtual environment. Um, ADK works with Python 3.9 or higher. So it's always a good idea to create a virtual environment. We activate the virtual environment and pip install the Google ADK package. With the ADK package installed, the next step is to create our project structure. And we'll have the parent folder, and inside it, a folder for an agent, and let's call it my simple agent. And if you're using Cursor, you can just take a screenshot of it and upload this. But I must warn you, Cursor tends to over-deliver, and it'll definitely code out um, everything inside it too. And for the Google API key, uh, you can use the AI Studio, which gives you free API keys to kind of experiment with. And the .env file is where we'll put our API keys for the LLM. And as I previously mentioned, if you're using Google's Gemini models via Google AI Studio, you'll just add your Google API key there. And if you're using Vertex AI, you'll configure project details. And ADK's documentation has clear instruction for this. And now kind of the exciting part, the agent.py file. This is where our agent's logic will live. We'll start with some basic imports for the date time and zone info for time handling, and the core agent class from Google ADK.agents. Um, Agents use tool to perform action. Let's define a Python function as a tool to get the current time. And if you notice the doc string, it's important because the LLM uses it to understand what the tool does and how to use its parameters. And we'll start by creating a simple function for a select set of cities, and we will just, if it's not in the list, we'll just say those are kind of the unsupported cities. And the clarity in the tools doc string, especially the arguments and returns description, directly influences how well the LLM can utilize it. This is an example of how ADK encourages good prompt engineering practices from the outset. Um, the second bit is to kind of create our agent instance. We'll name it. So specify the model. I'm using a Gemini model via Vertex AI configured to my .env file, and we'll probably need to give it a description of its capabilities, a system instruction to guide its behavior, and pass our current time function in the tool list. So for the model identifier, I've used the Gemini 1.5 Flash, which is more than enough for the simple task that we tend to do. And you could probably get more descriptive here with the description and something like an AI agent that can tell the current time in various major cities like New York, London, Tokyo, and Paris, as defined in the function call, the tool function call. And for the instruction bit, you could be like your really helpful assistant. When asked for a time in a city, use the current time tool, respond clearly with the time, and if the city is not provided, politely inform the user. So the the root agent variable is important because it's what the ADK command line tool will discover and run. And finally, in our simple agent init file, we just need to one line to make our agent accessible from .import agent. And there you have it. Our agent used tools and gave us the time. The ADK web UI is fantastic for this kind of interactive testing. You can directly run it in your terminal using ADK run my simple agent for command line interface. Our agent is simple, but ADK is built for much more, especially multi-agent collaboration. How do agents work together in ADK? Well, there are three primary mechanisms. The first, the shared state session. Agents in the same session can read and write data to a shared session state object. This is great for pipelining data from one agent to the next. Second, the LLM-driven delegation. An LLM agent can intelligently decide to transfer control to a specialized sub-agent using a built-in transfer to agent function call. The LLM essentially acts as a smart router. And third, the explicit invocation using agent tool. You can wrap one agent so that another agent can use it just like in any other tool. This allows for direct control calls between agents. Well, we didn't build a multi-agent system today, but understanding these patterns is key to unlocking ADK's full potential for complex application. These mechanisms provide the flexibility to design interactions ranging from simple data handoffs to sophisticated dynamic collaborations. So quickly, to recap the session in a few minutes with minimal Python code, we set up our environment, we define a custom tool, initialized an agent with an LLM, and successfully So to quickly recap this section in a few minutes with minimum Python code, we set up our environment, define a custom tool, initialized an agent with an LLM, and successfully interacted it with using ADK's local testing tool. This really showcases the developer-friendly nature and rapid prototyping capabilities of ADK. What we built today is just a small taste of what's possible. The ADK is an evolving framework with an exciting future. The Python ADK is now at version 1.0.0, signifying stability and readiness for production environments. And for enterprises heavily invested in the Java ecosystem, Java ADK is version 0.1.0 is rapidly developing, aiming to bring the same powerful agent building capabilities to Java developers. This dual language support is a strategic bridging the agile AI development often seen in Python with the robust need of large-scale enterprise system. A cornerstone of ADK's future is the A2A or agent to agent protocol. This is a game changer. Google is spearheading this open initiative with over 50 industry partners to create a common language for AI agents to collaborate regardless of the framework or vendor they're built on. ADK is designed to be the first class citizen in this interoperable future, allowing agents you to build with ADK to seamlessly communicate with agents built using LangGraph, Crew AI, or others. And when it's time to go from your laptop to cloud, ADK integrates tightly with Vertex AI Agent Engine. This provides a fully managed runtime in Google Cloud to deploy, test, release, and scale your custom agents with enterprise-grade security and reliability. This pathway from local development to managed cloud deployment is critical for building real-world impactful AI solutions. Expect to see a continuous expansion of pre-built agent patterns, more sophisticated tools, and deeper integrations with Google Cloud ecosystem, such as application integrations for securely connecting agents to enterprise data sources and applications like SAP or Salesforce. The bigger picture here is transformative. ADK, as part of Google's broader AI strategy, empowers developers to build the next generation of AI applications. We're taking we're talking about hyper efficient personal assistants, AI that can conduct deep specialized research, automate complex enterprise workflows, and even enable teams of AI agents to tackle problems previously too vast or integrate for a single AI. It's about moving AI from being a niche tool to an integral, reliable, scalable layer across all of our digital experience. So, to quickly recap our journey, Agent Development Kit is a powerful open source code first framework. It's modular, model agnostic, and designed for creating everything from a simple tool using agents to sophisticated multi-agent system. And as we saw, getting started with Python is refreshingly straightforward. Are you ready to embark on your own agent building adventures? The best place to start is to visit the official ADK documentation at google.github.io/ADK docs. Explore the sample agents, experiment with quick starters, and consider joining the growing community. The world of agentic AI is rapidly unfolding, and with tools like Agent Development Kit, you have the power to not just witness this evolution but actively shape its future. And thank you so much for watching. If this sparked your curiosity, give this video a like, subscribe for more content on AI development, and most importantly, happy agent building.